Okay. So I'm going to go through a little bit of an overview of Arup, who we are, global and local context in terms of organic processing, and then I want to talk about anaerobic digestion in particular. A European case study. We were lucky enough to go and visit a site in northern Germany last year, and I guess just to share some of the insights from that visit, and then any questions if you have them. So a little bit about us. We're a global company. We've got nearly 90 offices right around the world, 14,000 planners, designers, engineers. I work in the the Environment and Resources group. We're a fairly diverse group within Arup, energy, water, waste, which is the area that I'm in, resource recovery. But we also do large road building projects, a lot of big infrastructure, roads, rail, maritime, etc. Importantly, one of Arup's, we're very proud to be the technology partner for the Ellen MacArthur Foundation. That's a big part of our business. And Arup as a business has also adopted the Sustainable Development Goals, and we've got that in our constitution. We try to live that in the way that we do business. So, a bit of a global context. A huge amount of organic waste is produced in the world globally, 1.3 billion tonnes it's estimated, which is equal to a third of all the food that's produced annually, which is just a monstrous figure really when you think about it. So it's a huge problem, but it's a big opportunity in terms of being able to deal with that organic waste better and the opportunities for doing that. And in many places around the world, we see governments that are actively putting policies in to encourage the recovery of organics. Some of the options for recovery of organics. One is for the mixed waste, the MBT. The other two for source segregated waste. These are just two, obviously, but the main ones: composting of food and green, or FOGO together. And anaerobic digestion of, again, food and green, or FOGO, together. In terms of New South Wales, there's been a significant investment in MBT facilities, and we heard from Rob earlier, over the last 20 years. Late last year, the EPA withdrew the exemption for the application of MWU, or Municipal Waste Organic Output. And the reasons for that given were that there was limited agricultural or soil benefit, and there was a concern over physical contamination and glass. So I'm not here to really debate the whys and wherefores of MBT or otherwise, but obviously, and it's not clear what that outcome will be in terms of EPA's decision. But there is a closer spotlight on other ways of trying to use the organics in a better way, and we definitely, there's been a lot of interest from a lot of our clients at Arup. Can we do anaerobic digestion? Can we compost? What can we do? So anaerobic digestion is simply bacteria, bugs break down the organic material to release the embodied energy in the organics and produce methane. Potentially that can either be purified and go into the grid, or it can be converted to electricity. Various configurations, batch and continuous processes. You can have a mesophilic or thermophilic process, which is just different bugs operating at different temperature ranges. High or low proportion of solids, two main types: dry, not really dry, but dry-ish, and liquid. Dry and wet processes. Single stage, multi-stage, etc. So there are a number of ways in which it can be done. Horizontal, in terms of dry anaerobic digestion, this is a Tony facility, which I'll talk about a little bit later. Mainly produced by European companies such as Compogas, Isom and Strabag. Mainly processing food and green organics together with low contamination rates. Vertical system, this is OWS using the Dranko system. It's still a dry system, but it's just a vertical configuration. Anecdotally, we understand that there are some problems with blockages in these systems, but with all of these, it's down to operation, it's down to preparation of feedstock, etc., etc. So there's pros and cons for each. I think one of the stated advantages of the vertical system is that there's no physical mixing. So you get away from maintenance issues with paddles, etc. Wet anaerobic digestion, the best case of that is probably the Earth Power facility, jointly owned by Veolia and Cleanaway. They use a BTA waste pulper. The food waste is tipped, there's no green waste in this system. Food waste is tipped into a pit. It then goes into the BTA waste pulper, which is a big hydro mixer, basically adds water, and produces a sludge. It goes through a grit removal system and then subsequently into a anaerobic digester. So it's a liquid system. The outputs from that are biogas, and then it produces a prill that can be applied to land with the appropriate exemptions. So the case study I wanted to talk about really and focus on was a site north of Munich. I visited that early last year. The facility is provided for the municipality of Augsburg, and it's an integrated waste management facility. So it's not just anaerobic digestion, it's got AD, it's got composting, it's got a waste-to-energy facility. It's a truly integrated system. It's got a MRF as well, which is privately operated and owned. But it operates as a not-for-profit, so it's provided for the residents of Augsburg. They use a Tony AD system. It's been in operation since '94. There's 350,000 tonnes per annum processed through the whole facility, which is significant. And there's 85,000 tonnes per annum that is processed through the AD facility, which again is significant. Waste receival, big haul, it's all undercover. That's a Remondis truck, I think it was, tipping on the floor. They get about 24% of the total waste stream at curbside presented as FOGO. I was told that the contamination rates were very low, 1.5% to 3%, depending on the seasonality, but very low. The material's simply shredded down to less than 60 mil. There's a star screen to take out plastics and the like that might have got through at curbside. It's then screened, iron's removed or ferrous materials removed, and then it goes to the buffer hoppers. The buffer hoppers are a really important stage because they take out the seasonality really of the waste that's brought into the facility, so that the digesters can be fed at a controlled rate. So in terms of feeding the digester, difficult to see what's going on that slide, but the grey building at the top to the right is the digester, and the silver and blue processing unit is where the food in the green that's been shredded is mixed with water. It's heated up to, I think it's 54 degrees, and then it's pumped into the digester. And it's pumped into the digester at the far end of the photograph. The Tony digesters are really simple, relatively simple design. They can either be steel or concrete, but they're gas-tight structures, obviously, because they're producing methane gas. The shredded material is injected as a sludge. It's injected at the right side of this picture, moves to the left. The paddles move very, very slowly, and the residence time is between 20 to 23 days. And it basically just moves through, filling it at one end and pushing it through the system. So the paddles themselves are not necessarily moving it through, but they agitate the material, they liberate the gas, and they just keep the whole system moving. That's a shot inside of the digester, obviously before any waste has gone in. I think that was an early publicity shot. As I said before, the material's heated up to 54 degrees. It's about 30% in terms of moisture content. That particular digester is 33 metres long, and the paddles are rotating very, very slowly at 0.3 revolutions per minute. So it's a very big system. It's got lots of engineering redundancy, which is very important. The dewatering stage, very simply, the liquids are separated from the solids. In this case, and it's very important, I guess, in terms of the economics of looking at these types of systems, the liquid is supplied to farmers, and farmers basically come to the facility and pick that organic rich liquid up, and they take it and use it on their farms. The solids are then taken into the composting system for further processing and supply again to the surrounding area. It goes into an in-vessel tunnel composting system. Just briefly, it goes in there for about a day, I think they told us, which is purely to take it from an anaerobic system into an aerobic state. So really to kill off those bacteria that are working in the absence of oxygen and to turn it aerobic. And then when it goes into then the composting system, they get rid of some of those odours. They start, it starts to deal with that issue. Composted inside the building. The windrow systems, aerated floor, but they also use compost turners. It's after pasteurisation, which is between 6 to 8 weeks, I think is the local regulation for Augsburg or for Germany. It's then sieved and they take out everything that's greater than 10 mil. So that's what the rejects look like. The energy from waste facility effectively takes the rejects, so there's no cost to them insofar as there's no gate fee, and it's about 12% of the total inputs. Some of it I think is recycled back, but I think there's about 12% in total when you look at a year's production. So the final compost product was excellent. Didn't see any contamination in the product at all. Obviously that's a function of the quality of the material coming in the front, the contamination rates, education of the local community, so a whole raft of measures really to get that quality of the input material up, and some fairly simple processing at the front to take out that contamination. That's a picture of the biofilter. In Augsburg, actually, they don't produce electricity, but the gas is sent to a purifier. It's purified and then it's sent to the gas grid, and it's used by local industry and residents. And that's a biofilter from the air from the composting hall. So a quick overview of the mass balance. So every 100 tonnes, and the cost to them without any profit is about $200 a tonne. There's 20 tonnes of compost produced, 30 tonnes of liquid, which, as I said before, goes to local farmers, 12 tonnes of reject, and about 9,000 cubic metres of gas for every 100 tonnes. So the horizontal system, pretty simple, relatively low maintenance, we were told, and it takes advantage really of on-site treatment. This whole concept of having waste to energy, anaerobic digestion, composting, all on one site to get the synergies from all of these different industries together. Fantastic. So conclusion, anaerobic digestion is well proven in Europe. It's working in many configurations. There's many options to look at. Some of those players operate in Australia. Augsburg, as I said before, is a good example of putting all of these technologies together into a single place. There's a huge opportunity if you think about the volume of organics which is not processed, 1.3 billion tonnes globally. But I don't think the commercial and the policy settings are quite there yet in Australia. I think when you look at Germany, when you look at other countries through Europe, when they're choosing anaerobic digestion to to get the embodied energy back over and above, I guess, the composting benefits. But they're doing that in the context of subsidies on, not subsidies, but they're getting additional revenue from the government on electricity produced from organic waste, which is a substantial driver for them. And we don't have that here. I think we need comprehensive policy settings if we wanted to drive some of these technologies and encourage some of these technologies to be used in Australia. So they're not there yet, and I think the other thing is we need some certainty in terms of regulation. I think that's absolutely paramount in the context of, I guess, the last few years. We need some certainty in regulation to encourage investment. Thank you.